And this is another way to just think about putting the information together. There's the what, the hazard, the how, which is the pathway, how the hazard can get to where you don't want it to go, the model, which has to include your assumptions, your uncertainty, your rating scale, and then all of that adds up to the risk characterization. And we're going to do this in the small groups when we break up, but developing the model, again, starts with drawing a picture, identifying those critical control points, identifying data gaps, and refining your question. So I mentioned, for example, that if I was going to start with that question about what's the risk of leptospirosis in Indonesia during the rainy season, that's a specific question, but it's very broad. Okay, so I would very quickly refine my question and gather data for a more narrow question. So adding reality to your model, this is an example of qualitative data. It's appropriate for a rough draft of your model, or if you really don't have any numerical data available. And it can be visual. This is called a heat map. So you can use colors to show that, okay, very low risk here in the light yellow, all the way up to very high risk in the dark red. Okay, so that's a very quick way that somebody can look at this. It's not scary. Anybody can understand this. This is really easy for people who are not mathematicians or statisticians, maybe politicians, to understand. So a lot of times, even if you have numerical data, quantitative data, you might want to present it this way depending upon your audience. Okay, and your outcome can be low, medium, or high risk. There is, some people use a type of risk analysis called semi-quantitative. It's kind of fudging in between qualitative and quantitative. It's a little bit controversial. Some people like it, some people don't. That's fine. All it does is really create categories. Okay, and again, if you don't have a lot of hard data, you can create these categories. You can see, percentages ranging from less than 3% to greater than 65%. You can give them numerical scores that correspond to low, medium, and high. Same kind of thing, but you sort of fake some numbers. Solutions for lack of data. What if you have a qualitative model, but you really would like to get some numbers there? What do? Get more data. A lot of times it's a really, really effective way to help lobby for funding to do research, either from your organization, from a funding agency. If you can show a particular problem, hey, we have this really risky situation, whatever it is. If you can tell the story convincingly, this is an important problem. We don't have enough information to make the right decision. We need more data. Okay, this can be a really good way to help people understand why is this data important? What's it going to help you do? What's the outcome going to be? Okay. Collaborate with mathematical modelers and use methods. They can help you use methods that work well when you have a little bit of data or imperfect data. And then really, really importantly, you have to communicate your uncertainty. The uncertainty that's in the data with the politicians, the decision makers, with your boss, and leverage that for more funding. Go back to the beginning. It's an iterative process too. Is everybody familiar with the saying "garbage in is garbage out"? Right? No? This is what this is saying from where I come from. Garbage in is garbage out. So if you have bad data, just putting it in a mathematical model does not miraculously make it good data. Okay? And remember that you don't need numbers to start a model. So risk management, once you've done that risk assessment step, the what is it, how is it, how bad is it going to be, what happens if this thing gets where I don't want it to, risk management is the next step. That's the process of deciding upon what am I going to do about it, either to prevent this hazard from occurring, or if it does occur, to try to minimize the effects and minimize the impacts. And risk management is really based on understanding where those important control points are. What are the most important places that you can intervene to make the biggest difference for the resources that you have? And understanding the things that you can do that are the most cost effective, because resources are always limited. Funding's always limited. You can't do all the things you would like to do. So you have to pick the best ones to do. The things that are going to be most effective for the money that you have. And then always, always, always looking for how you can make things better. Just remember, it's always a cycle. And then risk communication. Remember that in the colorful diagram with all the circles? Yeah, risk communication is right in the middle. And you're supposed to be doing what you can to over-communicate. Share information with everybody, even the people you think don't care. They might not care, but they might really care. And I've seen circumstances where people have been plugging along headlong on a risk analysis, something that they think is really important, something that they can potentially justify why it's important to what they're working on as population of wildlife they're managing. They forgot to tell somebody, though, who's got the ultimate decision, and maybe it's their boss or even a higher up, who's going to say, well, that's great, all that work you've been doing, but the realities are we're never going to be able to fund that or make that choice or do anything based on this. So you might have just wasted time and money. So it's really important to communicate as broadly as possible. And that communication also helps engage the stakeholders more. And it helps you get better information. Because if you engage more of the stakeholders, more of the people that are impacted by whatever this thing is that you're working on, you're going to get better information put into your risk analysis.